Here we have a SAT math question. Let's go with the information. A man walks around a rectangular field at 6 km per hour and completes one round in 2 hours. If the area of the field is 8 square kilometer, what is the difference between its length and width? Okay, so a man walks around the rectangular field and it completes one round in 2 hours. So the distance covered by the man in this time 2 hours equals to the perimeter of the rectangular field, because he completes one round. That is, he completed the rectangular field in 2 hours. So to find the perimeter, what we need to do is we have to find the distance walked by the man in 2 hours. Okay, so perimeter is equal to the distance covered by the man in 2 hours, and there is a formula to find the distance. That is, the speed has to be multiplied by time. So here the speed is given, the speed of the man is given, that is 6 km per hour. It has to be multiplied by the time taken by the man, that is 2 hours. So 6 times 2, we get 12 kilometers. Perimeter of the rectangular field is 12 kilometers. And so already we know the formula for perimeter of rectangle, that is 2 times length positive width. Okay, now let me divide both sides by 2. When I do so, this 2 will cancel. I'm getting L positive W equals to 12 divided by 2 is just 6. Okay, now in this equation, I can solve for one of the variables in terms of the other one. So for example, if I want to solve for L, then I'll be getting the solution in terms of W. Okay, now let me solve for L. So for that, I have to get rid of this positive W. So I subtract W from both sides. Then I'm getting L equals to 6 negative W. Okay, now let me consider this is equation number 1. Okay, now I'm going to use the other information in the question. That is, the area of the field is given, that is 8 square kilometer. That is, area of the rectangular field is equals to 8 square kilometer. We know the formula for area of a rectangle, that is length times width is equal to 8. And we know the stuff for L, that is 6 negative W. We can plug in that 6 negative W for this L times W equals to 8. Okay, now we get an equation in just only one unknown, that is W. We can solve for W in this equation. So for that, we have to simplify the expression we have over here. So let's distribute this W to 6 and negative W. When I distribute this W to 6, I'm getting 6W. And when I distribute this W to this negative W, I'm getting negative W square equals to 8. Okay, now let me rearrange the terms over here. First, let me write the leading term, because it has the exponent, the largest exponent. Negative W square positive 6W equals to 8. So now we have a quadratic equation in the variable W. So usually to solve for the variable in a quadratic equation, we write the quadratic equation in standard form, that is ax square positive bx positive c equals to 0. That means we must have everything on the left side, on the right side we must have 0. But here in our quadratic equation, the right side is not 0, it's 8. So let's subtract 8 from both sides. When I do so, the positive 8, negative 8 will cancel. I'm getting negative W square positive 6W, negative 8 equals to 0. Usually we keep the leading term as positive, but here the leading term is negative. So to make this leading term as positive, better we can multiply both sides of the equation by negative 1. That is negative 1 times negative W square positive 6W negative 8 equals to negative 1 times 0. Now we can distribute this negative 1 to this negative W square. I'm getting positive W square, because negative times negative positive. Negative times positive become negative. 1 times 6W is the same, 6W. Negative times negative become positive. 1 times 8 is 8. Negative 1 times 0 is still 0. Okay, now I got the quadratic equation, that is W square negative 6W positive 8 equals to 0. Okay, now this quadratic equation is standard form. I think this quadratic equation can be solved by factoring. So for that, I have to multiply the constant term, positive 8, by the coefficient of W square. In this case, it's 1. Actually, we don't find any number in front of W square. We have to assume there is 1. So the coefficient of W square is 1. It has to be multiplied by the constant of positive 8. So when I do so, I'm getting 1 times positive 8 is positive 8. Now I have to get 2 factors for this positive 8, so that the product of the 2 factors equals to positive 8. And the sum of the 2 factors equals to the middle term, which is the coefficient of W, negative 6. I think negative 4 and negative 2 will work. So negative 4 times negative 2 will become positive 8. When I add the negative 4 and negative 2, I'm getting negative 6W. Okay, now so we have to divide both the factors by the coefficient of W square, which is 1. Even if I divide both the factors by negative 1, still I'm getting the same values, negative 4, negative 2. Okay, now even from these 2 factors directly, I can get the values of W. So to get the value of W, what I need to do is I have to change the signs of these 2 factors. So when I change the negative sign over here, then this number will become positive 4. That's the first value of W. If I change this sign, I'm getting positive 2. So I'm getting 2 values for W. One is 4 and the other one is 2. Okay, now to get the value of L, what I need to do is I have to plug in W is equal to 4 and 2 into the first equation. over here. Okay, now let me do it. Okay, first when W is equal to 4, what value do we get for L? So if I plug in W is equal to 4 over here, 6 minus 4, which is, it becomes 2. Okay, if I plug in W is equal to 2 into the first equation over here, then I'm getting L is equal to, when I plug in W is equal to 2, it will become 6 minus 2. 6 minus 2 is 4. Okay, anyways, we get the same dimensions in both the cases. That is 4 and 2. Here 2 and 4. The question is asking us to find the difference between the length and width of the field. In both the cases, if I find the difference between the length and width, I'm getting 2, because here the first case the difference between the 4 and 2 is 2, and in the second case also I'm getting the same difference, 2 kilometers, the difference between the length and width of the field. So we find 2 kilometers in option A. So the correct answer choice for this question is option A.